Welcome back in the closing video lecture of the Solar Energy MOOC program. For this video, I don't have a learning objective, but an action point for you. After following this MOOC program on solar energy, I hope that, supported by the knowledge you have gained, you will help in spreading the following message to everyone who wants to know. Solar energy plays a crucial role in the climate mitigation, the energy transition, and the realization of energy access for all people in the world. Let's have a short recap on these messages and their corresponding challenges. We have discussed earlier in this course the various CO2 reduction scenarios to combat climate change and to meet the targets of the Paris Climate Agreement. The blue lines correspond to the CO2 reduction scenarios that limit the increase in the global surface temperature to 1.5 degrees Celsius, the light blue line, and 2 degrees Celsius, the dark blue line, in reference to the temperature in pre-industrial times. This can only be realized if we drastically redesign our energy system into a future energy infrastructure in which fossil fuels are replaced by renewable electricity. Wind and solar energy is directly converted into electricity using wind turbines and photovoltaic modules. The entire energy value chain is predominantly electrified to decarbonize the industrial, residential, transport, and agriculture and public sector. In the IPCC's report on the mitigation of climate change in 2022, this bar graph was published. The graph shows the potential contribution to net reduction in CO2 emissions by 2030 per technology. The length of the bar shows the amount of net reduced CO2 emissions expressed in equivalent CO2 emissions per year. The colors along the bars represent the cost per additional reduction in net emissions. The blue color represents that the corresponding technology is cheaper than the reference based on a CO2 emitting fuels. The graph basically shows that wind and solar energy are the technologies that on short term can have the biggest contributions to replace CO2 emitting energy technologies with renewable electricity. In addition, these technologies are for large part, see the blue color, cheaper than the fossil-based technologies. This fully supports the results of the earlier discussed model entitled Global Energy System based on a 100% renewable energy future. This model simulates global energy transition for all regions in the world in detail from 2015 towards a 100% renewable energy system in 2050. Note that this model does not need carbon capture in the second half of this century to meet the targets of the Paris Climate Agreement. The model shows that to realize a 100% renewable energy system, the role of wind and solar electricity has to grow significantly. This means 80% of the energy in the form of renewable electricity is supplied by wind and 69% by solar energy. Let's look at this projected global needed capacity in wind and solar power for 2050. As earlier discussed, using this graph, this means solar and wind capacity needs to maintain an exponential growth of its annual market up to 2030 to 2032 to establish the required annual market needed for the next 25 years after 2030 to realize this 69% share in total mix of power capacity. It means that in 8-10 years from now, an annual market of at least 3 terawatt peak per year should be realized. In this graph, the realized cumulative installed PV power up to 2022 is shown, represented by the yellow bar. Note, this is not effective power but the rated or nominal power installed. The red bars show the annual markets of added PV capacity. This trend has followed for the last 2 decades an exponential trend. However, the annual markets, the red bars, do not seem to follow an exponential trend anymore in the last years. Let's go back to the previous graph. The gray symbols represent the effective wind power and the orange symbols represent the evolution of the effective photovoltaic power. Note that the orange circles are the forecast of the annual market for the upcoming years. A side note should be that in the last 20 years, market forecasts structurally underestimated the real annual markets realized. The red dashed lines corresponds to the trend to establish a 3 to 6 terawatt peak per year annual market within 10 years. Even if the orange trend is underestimated, the black arrow shows that we are at risk to deviate from the needed red exponential growth trend. What is limiting the further exponential growth of the annual photovoltaic installation market? The main reason is that the supply chain of production of modules and photovoltaic system components are mainly produced in one single region in the world, mainly China. This supply chain is still growing impressively in China, but its growth at a certain point will be limited to some physical limitations like circularity, material supply, and logistic limitations to distribute PV systems around the world. This graph demonstrates that the world is in need of establishing regional supply chains. This means that PV modules and system components need to be produced in South America, in North America, in Africa, the Middle East, Australia, Europe, and all over Asia. Everywhere around the world, a 3 to 6 terawatt peak per year market cannot depend on a global supply chain dominated by a single region. It needs a regional supply chains. It means that the governments and the financial sectors in many regions need to change their mindset and set the policies and investment in place to realize a quick upscaling of the regional supply chains. It is needed to mitigate climate change. Upscaling to terawatt scale markets faces circularity challenges as well. Are the material supply chains upscalable to facilitate these terawatt markets? We have discussed this example if you would consider a near future production increase of the PERC models to 1 terawatt per year. The required material amounts are of course raised by a factor of 5 in reference to the current material utilization. As discussed, this will further put extreme pressure on the polysilicon and silver production, but also leads to the requirement of a substantial amount of the worldwide yearly production of glass, aluminium, and copper. First, this shows the need for future technologies where significantly less materials need to be used to produce the same amount of PV power capacity. Secondly, it shows that recycling of PV system components like modules is a crucial aspect to realize a sustainable value chain for photovoltaics. PV systems should be circular by design. In the course, we have discussed the worldwide access to the energy and electricity in the world and the role it plays in the people's living standards. We still have several rural regions in the world that lack an electricity grid. Photovoltaic systems, here presented in the form of a solar home system, are a logic route to further improve the access to electricity in these rural areas in the world. However, how simple it might sound, we have to realize that the so-called climbing the rural electrification ladder also has its challenges. Energy access is not a binary state, a have or a not have condition, as envisioned in the past. It's a multi-tiered state. Additionally, the intended consequences of electrification, which is to increase the quality of life, is also an unintended consequence. This is because the increase in standard of living comes with increased electrical demands, or the so-called climbing the rural electrification ladder. Thus, a system perfectly designed for a particular set of appliances is rendered obsolete as the user climbs the electrification ladder. A strategy to scale the capacity of the solar home systems in time needs to be included. With these words, I would like to conclude this Solar Energy MOOC program. I hope you have enjoyed the content we have offered you in these 3 courses. I hope you have gained knowledge that will help you making decisions on, for instance, the program of choice to continue your studies or the future path of your professional career. In name of the course team, Thierry de Vrijer, Matteo Bariccio, and me, it was a great pleasure to serve you and interact with you in this course. And don't forget to spread the message to everyone who wants to know. Solar energy plays a crucial role in climate mitigation, the energy transition, and the realization of energy access for all people in the world. I hope to see you in a future course.